a couple of things here that we need to kind of talk about. The first is, how are we going to actually work with real hardware? Well, yeah, you remember these things? Yeah. No, because I made sure to buy good ones, okay, from Athena, which is still a U.S. supplier. I think I've maybe mentioned this. They still supply them, even the 8-inch floppies, because that's what nuclear weapon silos still use. Yeah. Yeah, well, I mean, it's either that or your nuclear weapons run Windows 10. So take your pick, okay? All right, so yeah, live Commodore hardware. Now, I have two things on here. The first is this, well, you guys can't see it through the screen, but it's a little SD card reader that interfaces with the Commodore, and the Commodore just thinks it's a giant disk drive, okay, which is kind of cool. And then, of course, I've got the actual disk drive involved. Okay, and so what I want to sort of start us talking today is how to do assembly, OG assembly, for real on the Commodore, no nothing, or no, sorry, I need to, uh, got the wrong thing here. All right, give me just a second to find the right file. Where did I put it? Of course, I've misplaced where I put what I'm looking for. Maybe I put it in here. Okay, well, whatever. I've managed to misplace a file, and but that should be okay. Yeah. Okay, whatever. I'll just make it over. So, we've got here a piece of software, okay, called Turbo Macro Pro. Now, how you run this is a little different than other stuff. So there's two things. One, the SD card. How do we use that? Okay. Now, I'm going to configure all of the SD cards to be drive number 11. Okay, because the disk drives, there were several models of disk drive, but the one that there's the most of is called the 1541, and it defaults to being drive number 8. Okay, which you guys are of course used to using. Um, Drive, but it could be changed to a different drive. Though with the 1541, you had to actually open the thing up and change some soldering to change which drive number it was. Okay. Later models of the disk drives have little switches on the back that make it really easy to configure which drive number the disk drive was assigned to. Okay. Um, and the SD card reader plugs in to the disk drive port, and so the computer thinks it's just a giant disk drive. Okay, so uh, a few things will be different about when you're using the machines upstairs for this than what I've got here. Okay, first is I have my actual floppy drive here set as disk 9, not disk 8. Okay, that's a very minor difference. And then I've got my SD card thing set to be drive 11 rather than drive 8, which is what it would default to when you first buy one of these things. Obviously, you can't have two things that are both drive 8. That doesn't work. So, hence the change. Okay. So, anyway, to use the SD card, oops. Okay. So, it's loading off the SD card, and this is the contents of it. Okay. Now, I've got a few things on here. I used a starter image with a link to which I will put on Canvas, and I've got SD cards for everybody, by the way, so you don't need to buy them because yeah, it's my day of giving, right? Day of giving you all Fs. So, yeah. You know how many people were in my 8 a.m. class out of 12? 5. Mm-hmm. 2 emailed me that they were not feeling well. So essentially, 5 people ghosted me. Okay, so the way that I can use and view what's on the SD card is if I load the program called FB. That's it, just FB. Well, actually, we'll do 64, FB64 from drive 11. Okay, and then run it. It will open up this file browser. Okay, which will allow me to view the contents of my thing. Okay, and now how do I work with this? On your computer, you have 4 arrow keys, right? Up, down, and left, right. There's only 2 on the Commodore. So how do you go up? You have to hold Shift and then the up cursor button. And down is just the cursor button. Similarly for left and right, okay, which I don't need here. Okay, so all of the software, you want to put it, you want to organize it. So if you go to CBM and then C64, then you'll see a directory structure. If you hit S, it'll sort it alphabetically. Okay, but if I go in here, there's nothing in a lot of these folders, but there are some things in others. Okay, this is a D64 file that just happens to already be there. Okay, and we can go into some of the other letters and see if there's anything there, right? Okay, so some of this stuff is just preloaded software that the people who make the SD, or the people I bought the SD2 IEC from, just put together some sort of some samples, okay, of stuff. All right, now the program we're going to use, okay, so let me actually quit this, and then let me go back to my, okay, oops, it's not what I meant to do. There we go. Okay. So there's another program on here called SD Browse, and for some reason they put the program .prg as part of the file name. It doesn't need to be. Okay, this will take a minute to load. Okay. Yeah, the disk drives on these things were notoriously slow back in the day. And the reason for that was that, well, I'll explain that in a minute. Okay, so it's going to load this browser. Okay. Okay, and it loads 2 copies of it. Now, what I can then do is, let's see, what was the key for it? Oh, and of course, now I've forgotten. I had this open yesterday, and I think I accidentally closed it. Here it is. Okay. So the list of instructions. So I needed to change. Okay. So I need to go Control to tab over here, and then I need to do Commodore B, and I want to change the second drive to drive 9. Okay, so now it's reading off of the disk drive. And it'll take a minute to load it, obviously. Okay, so what I did was on the SD card, you can put basically a just ton of D64s. Okay, when you run the file browser for the SD card and you select a D64, it mounts it, and then it's as if you have that D64 actually in a floppy drive, and you can do everything like you would normally. Okay, but this program gives me one other little tool, namely I can take a D64 and I can copy it to a real floppy. Okay, so I did that with my Turbo Macro Pro, the program, or sorry, that's what I copied. I copied it with this tool, and the Turbo Macro Pro is the thing that we're going to use that's actually on this floppy. Okay, now Turbo Macro Pro is an assembler. Okay, so it will allow us to write assembly code on the Commodore, okay, and assemble and run it on the Commodore. Yeah? Okay, which is cool, obviously. But the syntax and the way you type things will be slightly different than the way it would be on if we were using CC65, okay? Because this assembler is actually very old. It's been updated through the years by people who are, into this retro stuff. Okay, but anyway, this is how I made a program. Okay, now how do I quit again? Is run stop. Oh, okay, that's not going to work. How did I quit this yesterday? It says run stop key is used to abort or exit. Okay, that's not working. I'll just reset the machine. That's fine. No, I'll just have to. All right, so if I go to, I'm going to go now to drive 9, which is my floppy drive. For you guys upstairs, it'll be drive 8 because that's what I've configured all those floppies for. But I've got a whole bunch of stuff here, okay? Now, most of these programs are not, they're versions of the Turbo Macro Assembler for different configurations of Commodore, okay? In particular, you could get like a RAM expansion unit back in the day and some other accessories, and there's a version of this that supports using all of those different things. We don't have any of those, so we're going to be using the OG, just TMP, Turbo Macro Pro, that program, okay? So I'm going to load TMP from drive 9, and I'm going to add something that we haven't had to do before, which is a comma 1 after the drive number. Okay, so what that does is it allows the program to tell the Commodore where it wants to be loaded into memory. Okay, so you guys remember what was the very, very, very first thing of a tokenized BASIC file? Oh eight oh one, right? Or actually 0108 because it was in low byte, high byte order. That when the Commodore reads that, it says, "Oh, I need to load this into location 0801." Okay, so that those two first bytes of the thing tell the Commodore where to put the code. Okay, and adding the comma 1 will sort of force it to do that. Okay, so it's loading the program, and this will take a minute. Okay, because these floppy drives are not fast. The reason they're so slow, it's actually not the drive that's the problem. It's the computer. So the Commodore 64 was Commodore's third product, right? The first one was the Commodore PET. Then was the Commodore VIC-20. And right before the release of the VIC-20, they located a bug in the hardware, in the shift register that basically handled disk drive I/O. And a shift register is a hardware thing for basically taking serial data in and giving parallel data out, or vice versa. So there was this bug, and it was too soon basically to correct it before release. So what they did was, rather than correcting the hardware, they rewrote some of the software routines to deal with the problem in software, which slowed down things considerably. And then that would have been fine on the VIC-20, except then when the Commodore 64 came out, right, they wanted to retain backward compatibility with everything. And so the bug is still there. Okay. So this is one reason why this stuff is going to be slow to load.
Why wouldn't you just release a set amount, fix the problem in the hardware, and then keep a few of them back and sell it as like
The VIC-22?
It's like, oh, this is a special model with a flaw in it. Sell it like 10 years, 5, 10 years down the road.
People didn't buy things with flaws like that back then. I mean, this is the early 80s, man. You just don't get it. Yeah, these aren't coins. At least not back then. Okay. All right. So I've loaded the Turbo Macro Pro program, but I cannot run it by just typing run. Okay, there's a good reason for that. What I have to do instead is a syscall. Oops. 8 times 4096. Okay. Now, 8 times 4096 is 32,768. Okay, so I could have typed that instead. In fact, let me just do that for sake of demonstration. 32,768. Okay. Now, what is this sys command? That's actually a basic command, but what it does is it's essentially a JSR, right? So this is how you interface BASIC with assembly, is you can have a BASIC program call an assembly routine with the sys command. And then 32768 is where it's loaded into memory, the assembly thing. Okay. And so if I do that, then it will run my assembler. Right? Okay. So we need to write some code. Well, there's a couple of things that we'd want to do in a very simple program. One would be, yeah, how would we do a hello world, basically? Right? What do we need to do for a hello world? No idea. Okay, well, what would we need to do for a hello world program? What do we need? Okay, some sort of, we could have user input. Let's not even worry about that. We need something that can print a string, and then some commands to do that. Right? Okay, so we're kind of starting from scratch here. In particular, though, I need to have the following. Okay, star equals C1000 hex. Okay, so what this is going to do is I have to specify where I'm going to put this program in memory. Okay, and the assembler needs to know that in advance. Okay, because unlike modern machines, we don't have linkers or anything fancy to dynamically change this on the fly. Okay, so why did I choose C1000 hex for where I'm going to put my code? Mm-hmm. So yeah, so I had to put it someplace in memory, okay? And I can't put it at 8,000 hex because that's where my assembler is currently living. Okay, so I put it in C1000, okay? And I picked that location because I know it's free and that there's nothing else there. And so that's a safe location. I could have written code to put it in 8,000 hex, but then I couldn't like both have my assembler in memory and my program in memory. Now, you can't put a very big program at C1000 hex because by the time you hit D1000 hex is where registers and stuff and kernel routines are located. Okay, but I'm not going to be writing a very big program. That's a kilobyte of memory that's there. Uh, sorry, 4 kilobytes of memory there between C1000 and D1000, right? That's quite a bit of memory, and I'm not going to need nearly that much for just something stupid like Hello World. Okay, okay, so got that. What else do I need? Well, I need to define my my byte. Okay, and sorry, let me load up a couple of other things that I'd forgotten about to load. So I had a bunch of tabs open, and then of course I closed them because I'm an idiot. Oh, I also need no, wrong one. Okay, so I've got two different pages here. One of them is the Kernel API, and I'll put a link to this on Canvas, but there's a whole bunch of kernel routines, okay, to do various things, okay, and let me turn off the German one. Okay, and essentially what I need to do here is I want to know what functions do I have to work with the Commodore already has built into its ROM. Okay. Amongst other things, I do have the ability to print. Okay, so let's actually just do something kind of equivalent to a basic program that we wrote. Okay, what did we do when we wanted to? How did you guys do the print without printing? Yeah, we poked. Okay, so how do we poke in basic? Poke what you're poking and where you're poking it. Okay, you need to know the address and what data you're putting there. And the data that you were putting there was a single byte, and the address was therefore just a single byte. Okay, with the text stuff, how did we? What did we poke and where did we poke it? Yeah, where was the top left? The top left was a memory address 1024. Okay, but that's 1024 in decimal. What is that in hex? Mm-hmm. 1024 decimal. What is that in hex? 400 hex. Okay. All right. Now, here's how I know that because 1,000 hex is equivalent to 4,000 4096 decimal, and this is a quarter of that, so 400. Okay. All right. So what I'm going to do then is I'm going to load into the accumulator an immediate value. And in this case, let me just load in 0, 1, whatever. Okay. And I'm going to store that to what memory address did we say? 400. Oh, And you see how it's highlighted it? Because that should be a $sign, not a immediate, because it's a memory address. Okay, so it will catch some syntax errors for you. Okay, let me just, that's it. Let me just do this as my program. Okay, sound good? Oops, I want, okay, so now I have a program. I need to assemble it and load it into memory and then run it. Okay, so for this, I've got the manual open for Turbo Macro Pro. Okay, so in Turbo Macro Pro, most of which the command key that you're going to use, okay, is this backwards arrow, which is to the top. It's literally the top left key. Okay, so it's just to the left of the number 1 on the Commodore keyboard. And on your way out today, take a look at the Commodore keyboard because it's not the same as your usual keyboard. Now, the letters and stuff are all in the same place, but like instead of the Windows key, like Microsoft didn't invent that. Like that's old school. Okay. All right. So what I want to do is I want to assemble this, and then let's see. I need to do, I'm going to do arrow 3, okay? And then it's going to go through and it'll run the assembly, okay? And it takes 2 passes for it to do this, okay? And the reason it takes 2 passes for it to do this is because I could have labels, okay? And the labels have to get replaced with actual memory addresses. So the first pass is it's just basically dealing with the individual instructions, and then the second pass is sorting out any labels. Now, in this case, I didn't have any labels, so there was no worry, okay? And so how much code does my program take up? 6 bytes, okay? Not a whole lot, right? Two of those bytes are to load the number into the accumulator. 3 of them are to store it to a memory address, and then the 6th byte is to return, basically quit the program. It's over. Okay, return back to the kernel. Okay, so now I want to run this, so I can hit S to start. Okay, and my thing is in fact running. Okay, so what happened here? Let me rerun it. What's going on here? Okay, I'm not sure why this is being so slow. Okay, I don't think I should have done that. Well, let me just reset it, redo it. Sorry. There's going to be a lot of this, by the way. Yeah, so there is going to be a lot of this, unfortunately, when you screw something up and then you have to reset it. And I should have saved my thing to disk, but of course I was stupid and didn't. Okay. All right, so let's try this again. So what did I do? I wanted org. Oops. Okay, and then we did load A. with the immediate value 0, 1, and store A to address, what was it, 4,400. Oops. And RTS. Okay, so arrow 3 to assemble. Okay, memory load, any other key to edit. Okay, then I'm going to quit back here. And so what is C? What is C in hex? Like C hex is what? Yes, A is 10, B is 11, C is 12. So I'm going to do 12 times 4096, right? That's C1000 hex, but I can't tell BASIC to execute something. I can't, BASIC doesn't understand hex is the problem, right? So now, what is 12 times 4096? You can calculate that and write that down, or you can just do 12 times 4096. So if I do this, what should happen? Okay, it ran my program. Okay. What happened, though? What should this program have done? Yeah, it should have stored the number 1 in a particular memory address. Okay, did we have the correct memory address? So this should have changed the character in the top left entry, right? Because if I had done this, okay, so poke, is it value then memory or the other way around? Okay, so then it would be poke 1024, 1. Okay, what's there? Nothing. Okay, so let's change what we were poking. Do I have the right memory address, by the way? Or was it 1,000? Yeah, where was the top left? Okay, that's what I thought. All right, so let me do like, nope. Do we have it? Are we sure we have it in the right order? Let me just double check. Yeah, that's right. Okay, so what was it? 1024, and let me poke 33. Okay, why isn't that doing it? Because I thought that we certainly did this before, right? With the print without printing? Okay, so you know what? Just out of curiosity, let me load the emulator because it is to poke that address. And why isn't it working here? That's interesting. No, it should be the same. I mean, the emulator is doing exactly that. It's emulating, right? Hmm. No, it did it. Because if I do this, all right, so Evan's suggestion is, oh, sorry. That's really weird. The emulator does it, but not the real thing. Hmm. Huh? No, because why would the emulator do it if the real thing wouldn't? No, because I don't want to have to reload the macro. Um, well, oops. I just hit the wrong button. Don't worry about that. Yeah, okay. So, yeah, it's because I hit a different button. Uh, oh, Yeah, maybe. Okay. Well, yeah, because I don't. Yeah, I can't list anything. So, all right. Well, this is an interesting problem then. Uh, let's not worry about it for the moment though, because there is a kernel API, basically kernel routines that allow you to print um, strings. Okay, so the let me find, where is it on my list here? Okay, so let me go back to uh, my assembler. Okay, and let's change some of this stuff up. All right, so I'm going to load and just um, let me just do this for right now. Let me just do 00 and, or sorry, that should be the X register. Okay, so I'm going to load X with 00. I'm going to do the same thing with the Y register. Okay, and then I'm going to do JSR to the address E50C. Okay, now that you may be like, where the hell did that come from? Okay, E50C is a kernel routine that puts the cursor at the location and you pass the coordinates that you want it to go in terms of its row and column using the X and the Y registers. Okay, so where should this put the cursor? If I pick row 0, column 0, top left. Okay, now obviously I could change those numbers. Okay, so that routine does that function. Okay, and there are a bunch of these kernel routines that are going to do various things. Okay, and then we just have to basically look at the list of them to see what they all are, or basically dig into the manual like we've done a billion times. Okay, now I'm going to put a string down here. Okay, and this is going to be um, make sure I'm saying this right. Okay, and then oops. Oops. Okay, so what I've defined here is I've defined a string. Okay, and why did I put this byte thing at the end of it?
You can say it's the error.
Exactly. That's the null terminator. Okay, so we previously, like in 241 and stuff, would put a backslash in or something, or just like our compiler or assemblers would automatically put a null terminator at the end of our strings. We don't necessarily have that. Okay, so I'm going to force basically, this is a sequence of bytes. Okay, and then I've got a 1 byte extra that I'm going to throw on the end, which is just the null terminator. Okay, now there is a kernel routine for printing a null terminated string, okay, and it happens to be at some memory address, okay. What information do I need to pass it? So I've already set where the cursor is going to be, so I don't have to do that again. But what information does the print command need? It needs to know where the data is that I want printed, okay. Well, where is this data? It's wherever the string here is stored in memory, which do I know that in advance? No, okay, because the assembler is just going to put it somewhere, probably at the end of our program code, okay, but I don't know what that memory address is going to be yet, okay. So there is a very nice command, okay, and let's see, I need the accumulator and watch this, okay. Okay, so what it's going to do here, you see the less than and the greater than symbol? One of those is going to load in the low byte, and the other one's going to load in the high byte. Okay, so the low byte is the one with the less than symbol, and the high byte is the one with the greater than symbol. Okay, so essentially here's the problem. I need to pass my print routine a memory address. How big are memory addresses on this machine? They're all 16 bits or 2 bytes. But my accumulator can only hold 1 byte of data. So I need to use 2 registers in order to pass the memory address. And the convention, or the way this kernel routine is written, is that you pass the low byte in the accumulator and the high byte in the X register. Okay, fine. Right? Okay. Nope. But I pass that to this function that's at E50C. And so that sets the cursor, and now the cursor's where I need, and I don't need to worry about it. Okay. Okay. So if I did this, then I want to JSR, and the routine I'm going to is at AB1E. Okay, AB1E. Okay, and then when I come back from that, that's it. I'm done. Okay. All right, so let's do that. RTS, and we should be ready to assemble it. Okay, so arrow key 1 is not the button I meant to hit. I meant to do arrow key 3. Okay. All right, so did this assemble correctly? Yeah, okay, no errors, so we're probably good, right? Um, actually, you know what? Look what's at the top left corner. That poke is there, okay? So actually, I bet you what we did is we forgot, um, we need to probably change a register to allow it to do the poking, because look what's there. It's that A, right? That's interesting. Okay, so let's go back to here. All right, and then I'm going to quit, and we'll do sys. Where did we say it was? 12 times 4096, and nothing, of course. So what did we screw up? Well, okay. No, I did. C1000, right? I told it to put it there. And let me just make sure that I'm not. Um, E50C. Okay, you know what? Actually, let me change this to what I have in my reference here. Reassemble. Oh, hold on. Maybe I didn't actually put it into memory. Uh, okay, so let me make sure that I'm actually loading this. Hold on 1 second. Okay, let me actually do one other option. Okay, I just saved the program to disk. Oops, that was not what I meant to do. Okay, what did I have here? I had LDY and then 0A. Okay, so let me quit. Oops. So you have to be careful. If you hit the arrow key and you're still holding it when you hit the 1, That's different than arrow key and then 1. And since they're right next to each other, your fingers sometimes do that. Okay, so if I load hello from device 9, okay, then I get an out of memory error. Okay, and that makes sense. Yeah, but if I do this, same thing. Okay, that's interesting. All right, well, let's try, what was it, 12 times 4096? And it's not printing the dang thing. That's really irritating, guys. But I do want to try one other thing. So the A we poked, still there. Okay. So that wasn't it because I just poked what should have been a B. And let's try hitting the start thing. Nope, that didn't do anything. Okay, well, I guess I'm just a big old fat idiot because I've done this before and it worked fine. Okay. All right, what was our print routine? AB1E. So I'm digging into the kernel source code here to look at. Maybe we've messed up which registers to use. AB1E. And, I think that's why. Because, yep, that's why. Your professor is a moron. And that should have been the Y register. Oops. Dang it. So I was giving it garbage data to print was the problem. Okay, so assemble, Gucci. Okay, let's quit. Oops. And let's try it again. What was it? 12 times 4096. Damn it. Okay, I don't know why this isn't working, guys. All right, so A register is the low byte. Y register is the high byte. AB1E. And yeah, I don't know why that's not working. Okay, so that should have put it in memory. All right, let's try this. Oops. 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 Need. Oops. Okay. So what I'm wondering is if I didn't actually put it into memory correctly, which is possible that I screwed something up. Um, So why don't we try actually this? Um, well, okay. I'll go through and figure this out, why this isn't working. But um, so one thing we can do is, let me just do a quick computation here. D is 13. Okay. Um, oop, 53,280. Okay. Let me try this. Okay. Now all that does is change the thing. So poke 1024 with, let's just put a 1 there. There it goes. Okay, so I think actually we just couldn't see it, right? Because now the poking's working. All right, so let's try our program again. Okay, I don't see hello world out there anywhere. Do you? No. Okay. So, well, that's possible. Okay. But if I did, all right, so let me try then this. Oops. Poke. I still can't see it. Okay, let me. Okay, so the poking's working. Um, yeah, I don't know why that's not working, guys. This is really irritating. Um, so, all right. Well, I'll figure out why it's not working and then tell you guys. All right. So anyway, the what's the big picture? I guess, right? Now we can do something with the Commodore itself. Okay. Now, let me maybe actually switch over the input for a moment to um, the full screen and come off the Commodore. Okay, and just show you what I'm referencing here once OBS decides to cooperate. Okay, oops. Okay, so okay, now it doesn't want to capture the display. Um, okay, it's OBS does not want to capture the display, but that's okay. So what I'm looking at here is, oops. So there's pagetable.com has a couple of really nice um, references, okay? And in particular, there's one of these that's several of them that are in German. So let me turn off the German ones. Okay, so we don't want that one German, and we'll turn that off. Okay, and we'll look at the kernel only. Okay. Okay, so if we look through this, right, there's a whole bunch of stuff, okay, but what was it, the thing that we were using to print AB1E? AB, oh, sorry, that's 8, not B. AB1E, okay. Print string from memory address from AY, okay? So what that's going to do then is this is how we give it parameters, and we could have actually done AB21 instead. And the only difference is basically like it's calling another thing. Print character on command output. Okay, so well, let me actually go back up. Sorry, and turn on, say, this one and this one and then this one. We'll just turn them all on. Okay, so let me go to AB1E. Okay, so print the thing whose descriptor is blah. Print string from utility pointer. Print string at fac low, fac high. Okay, but make y comma a printable. Okay, so we were calling AB1E, and let's see, we wanted AB1E. Yeah, there it is. Print a string pointed to by y comma a, which ends with a 0. If the string is below blah, it will be copied into string space. Okay, whatever. Right, so that should have printed it because we gave it the right stuff. I'm not sure why it's not working. Um, yeah, well, I guess I've got some more digging to do to figure out why it's not working, right? So, okay. But let's maybe just go back to the Commodore for a second. And I'm probably forgetting something here, which is stupid. Um, like, I'm probably forgetting, um, yeah, I'm not sure. Well, one thing we could try, and I'm not sure if Turbo Macler does it this way. It didn't give us any errors, but why don't we try this? Okay, so it doesn't like, okay, looks good. The only thing that maybe it's complaining about is, let's see if it requires a colon here. Oops. No, okay, it gets rid of them, that's right. Okay, so 3, And all right, so let's quit and still nothing. All right. Oh, that's interesting. Yeah. Yeah, why did it do that? That's odd. Um, let's but it said C1000 before, right? Well, let me just retype that. Maybe it okay. No? Okay, maybe it's put it not where I think it's put it. Let's try that. Let's do sys 1000 hex would be literally just 4096. Well, not quite. Well, no. Okay. Well, why don't we try? Let's put it somewhere else in memory and see if it doesn't complain there. So let's put it at 1000 hex. Nope. All right. Symbols to the assembly bank, which is in bank 0, and all mods supporting extra RAM are simply directly to C64 main memory on the unexpanded C64 mod. Okay. Oh, let me try this. Okay. Um, well, we're at the end of time, but all right, I'll figure it out. I'm being an idiot, but okay. Before I quit it, though, what I wanted to maybe briefly mention was the um, the interrupt handling, right, with the buttons on the breadboard. So the problem, of course, is how do you know that an interrupt has occurred? And Ben's schematic doesn't actually check for a hardware interrupt from the buttons. That's where we had the AND gate come in. Okay. Otherwise, what you have to do is continually pull the button register, which was the A register on the 6522, to see if the data has changed. And if it has, then do something. Okay. That's a bad way to do it, though. And yeah, okay. Um, all right. Well, I guess we can quit early today, and I'll figure out what the heck I'm being such a moron this morning. So, because I've done this before and it worked fine. So, um, yeah. All right. I'll see you guys later.